Following is an example of finding the volume by revolution. The volume we're asked to find is created by revolving y equals 4 minus x squared, this parabola, and the y-axis and x-axis, taking that region and rotating it around the y-axis. So we need to draw our representative rectangle. So in this example, a dx rectangle or a dy rectangle will work fine. So if we draw a dx rectangle, we notice as that rectangle moves from left to right, the top is always on the parabola, the bottom is always on the x-axis. So that rectangle will work fine. So since we know we're rotating around the y-axis, we've established our rectangle. This is the point 0, 0. This is the point 2, 0, or x equal 2 there. This is a dx rectangle, which is parallel to our axis of rotation. So we are using the shell method. Using the shell method, we need a radius, a height, and a thickness for the shells that we create. The thickness is dx, the width of our rectangle. The radius means the distance from the axis to the rectangle. So the distance from here to here is x. Remember, the radius corresponds to the thickness. The height is from the bottom of the rectangle to the top of the rectangle. In this example, that's the top curve for minus x squared minus 0, because we're on the bottom. The volume then is equal to 2 pi times the integral from 0 to 2, the x values, the radius times the height times thickness. 2 pi from 0 to 2. We multiply first. That gives us 4x minus x cubed dx. Integrating then gives us 2x squared minus x to the 4 over 4, evaluated from 0 to 2. And now substituting in 2 and 0, always starting up top, you get 2 times 2 squared minus 2 to the 4 over 4 minus 0 when we plug in 0, giving us 8 pi when we simplify it. And we're talking about volume, so that's units cubed.